Okay, so today's video is just going to be the second lesson of this functional mastery Cybertron workshop, which I explained in the video from yesterday. So this is just getting practice with map, filter, reduce, and compose. We're using the Ramda library for it's kind of like Lodash. It has it's a library of functional programming style functions, and we'll get started. So the first one is use map and the hex to color function to convert the list of hex values to a list of colors. So we have this hex to color function that's already imported. So here we can just do map. The first argument is the function, which will be hex to color. So this is the function that's going to be used to map over our array, and then hexes. And so we see we get one text passing down here. And so now we can go on to our filter. And so we can write our filter. So we'll just say filter, and this is going to take an X and return the hex to color of X if it's not equal to blue, red, or green. Blue and red and green. So this is the reason we're using and here is because the way this reads is blue, red, or green, so it almost feels like I should use the or operator, but we're wanting to filter out all colors, all blue, red, and green, and only get the colors that are not those. So to filter out all of those, we need to use and, because or will just return as soon as one is true. I believe I said that correctly. So then we can just do filter, and we'll do filter of the hexes. Okay, so now we get 2 passing. Okay, now we want to use reduce in the hex to color function to count the list of hex values that have R in their name. So we need to first so we'll need to, let's just write this out, we'll need to turn our array of hexes into colors. Then we will need to check if each color has an R in the name, and count those colors. Okay, so we can do reduce accumulator hex. We want to do hex to color hex of dot includes R, and then we want to do accumulator else accumulator, maybe, right? Okay, so then we'll check that out and do 0, and then the argument will be hexes. Okay, so let's read this. Hex to color of the hex includes our accumulator. This will be explicit. Oh, there we go. So there's a this one's passing now. Okay, so now we want to use map, filter, and reduce to convert all hex code to colors, then filter out blue, red, or green, and count all the colors that contain blue. So this is just going to be basically what we already have for most of these. And remember, we use our reduce first, so reduce accumulator hex. We don't need to do the hex to color. Convert all hex code to colors, filter out blue, and count all the colors that contain B. Okay, so this will be hex dot includes B accumulator +1, and then else accumulator, and then 0, and then our filter will be X X does not equal blue and red and green, and then we need to map, and that'll just be hex to color, and then this will be, we'll pass it to hexes. Let's see what we have. We need to do that. There we go. So what we're doing here, again, if we were to, the way this reads is essentially you see this compose function, you take the hexes, and we're passing it up the functions. So it's going into the map, and again, because they read left or right to left, so we pass hexes into map, and then so that does the hex to color, converts them all to their colors, and then we pass that into the filter function, which returns only the colors that are not blue, red, or green, and then we pass that into the reduce, which adds up all the hex colors that include a B in the name. So that is the second lesson. And just for, I'll grab these functions and I can show it with pipe as well if we want to care about that. In the future, pipe will be important on this website just because, did I import pipe here? Nope. Because I want to do some things with effect TS, and effect TS has a pipe function that is similar to this pipe function, but it just has a little bit different of ordering. It kind of runs how you would expect. So rather than having the argument here, you would pass the argument here in the effect pipe function. So anyway, that is our lesson 2.